Hey everybody, to start us off online, to pick up where we left off, we need to now, according to the College Board, cover chapters 10 and 11. And I had talked in class that we were going to mix this up a little bit and work with one sample procedures first, the confidence interval and the test, and then we'll move on to the two sample procedures. The reasons the conditions and formulas are so similar, and because we've already covered the basics of confidence intervals and tests, I feel like we can bounce back and forth and it can stay pretty fluid. If you have any questions about confidence intervals and need to go back to review, it's all things chapter 8. Test is all things chapter 9. The first 4 procedures that I have listed there, we're going to use our quote unquote IQ test data to work through. So what's new, how these are different from what we've already learned. We're just switching over to means from proportions, that's all. So essentially we're dealing with quantitative data instead of categorical. Our conditions are still random, independent, and the large counts condition, which is the one that changes significantly. So since we don't have a proportion and a claim about P anymore to check whatever version of NP and N times 1 minus P we've been checking, it kicks us off of using Z-scores and using table A and inverse norm and normal CDF, but we have now the T distribution and table B instead. I want you to do this on the calculator. It makes it so much easier, especially you'll see when we get to the 2 sample procedures. So what is the same, what is similar to what we've already done? These wonderfully long problems where we have to go through state plan do conclude, and generally procedure names, again, slightly just changing from T's to Z's. Otherwise they are, and from P's to mu's the same. Same basics of the formula. Confidence interval is still estimate plus or minus margin of error. And then the conclusion, same formats, again, just swapping out proportion and replacing it with mean instead. And then all that good vocabulary that we learned early on as well still applies. You are still responsible for it. So this was a pull from your book with a few notes added by me. So since the conditions are a big change, random, again, just a reminder that if we don't have data from a random sample, we can't make those inferences about the larger population. And then the 10% condition when we're sampling without replacement, which realistically is what we're doing. The formula will overestimate just slightly. And again, you don't really have to worry about direction so much with that, just knowing that it's for standard deviation to be accurate that we check this condition. So the big change is that we now have something that looks like a normal distribution, but it's not, because even though it follows a bell curve, that doesn't make it approximately normal. And so we are switching again from Z's to T's. And so this again is for that piece of the calculation that we're working with. So the 3 scenarios that really show up, and that's why I gave you the A, B, and C there. We could be given that this condition is met because if the population distribution is normal, then the sampling distribution of the sample means will be approximately normal, which is very, very unlikely, because why would we know so much information about the population? And so don't expect that one to happen, but it's a possibility. The second one, B, is to use some sort of display to take a look at the shape. So the old version of our book broke this down based on how small the sample size was. And then I wrote this up just in terms of some easy spots to look for. So are there outliers shown in the box plot? That's the best one since the calculator automatically checks that 1.5 IQR rule for us. And then does it appear to follow a bell curve in a histogram? So again, not every bell curve is a normal curve. It has to specifically have those proportions under the 1, 2, and 3 standard deviations. That's 68, 95, 99.7. But if we're at least getting close to it, then again, what we have in part C leads us into, if the sample size is large enough, then the sampling distribution of the sample means will be approximately normal, no matter what we don't know about the population and its shape. It is the central limit theorem to our rescue. So we'll be using that quite a bit. The visual from your textbook, and they show this picture a couple of times, is showing that the T distributions have more area in the tails, it says there, than our standard normal, which again is just fancy for showing it on that curve where we're centered at 0 and we have a standard deviation of 1. That's our standard normal. I always just refer to it as like shorter and fatter in the tails. And so that red dashed line is 2 degrees of freedom. It gets taller and sort of settles into a normal curve as degrees of freedom increase. Degrees of freedom for our one sample procedures are simply 1 less than the sample size. We talked about this back in chapter 1 when we were calculating standard deviation. We're going to use table B. It sounds kind of awkward, but we have to do something called a more conservative approach. And so I say rounding down, it's physically up the table, but we're going to take the degrees of freedom and round to a lower number. Or if we embrace what the calculator can do for us, it will find it exactly instead. And so the tables are in your formula packet and also in the online book. So if we switch gears and go over and take a look at sampling, first you'll see that I put the assignments up. We are doing them out of order from the book, again, because it's 1 sample procedures first and then 2 sample. These due dates will lock you out at 11:30. I set that just so that whatever dates I have on here will be consistent with what is initially posted on dashboard. I will adjust all of them the next morning to open up the window so that if you happen to miss that particular timing of it, you can still get it done and not worry about it. But again, and I'll explain it a couple of times, or remind you, I should say, a couple of times, that I'm doing this just so that for now things match what we're posting. So if you take a look at the textbook, just to show you what the difference is between the 2 tables. If we go to table of contents and go to the back matter for the tables, the table A, our standard normal table, what we're used to, we find the z-score to 2 decimal places, and this gives us everything from negative 3.49, working our way closer and closer to the center, and then to the positive side at the end. So table B is different in a couple of ways. First, if you look at this picture, the area is always to the right now. So this is telling us a tail probability instead. We can still end up with negative values for T star, our critical value, or our test statistic that we're going to call T. So it could still be positive or negative depending on whether it's below or above the mean. But for table A, everything with Z was always the percentile. It was always everything to the left instead. So keep in mind, this is always tail probability. And so you would just have to pay attention to, again, the distance here, not so much whether it's positive or negative. And then if you look at it, the top of this table is telling me the tail probability. So we see some common numbers here are 0.01, 0.025, 0.05. These values are the best that we can do. It's not telling us in between. So if I end up with a p-value of 3.27%, I'm not going to get that from my table. All I'm going to get from my table is that I'm somewhere between 0.025 and 0.05, somewhere between 2.5% and 5%. So across the top are the tail probabilities. Down the left-hand side are the degrees of freedom. So it works well for a while, and then we get to 30. And then we jump to 40, and then jump to 50, and so on and so on. So this was where, when I said we would have to round down, that's what I was referring to. We have seen this table before. I directed you to it for the confidence levels at the bottom as a little cheat, so that once you see that infinity row, this is where it has now met the standard normal distribution. And so the values that we would use would be the ones that we're familiar with from all things Z. So our 95%, you can see that 1.96 that we're used to. So the table is here. It is in your formula packet. Or like I said, to find the exact value at the particular degree of freedom, which maybe doesn't exist on your table, the calculator will be our best friend for that. And we are going to take a look at those first 4. Again, if I scroll back up here for you, these first 4 procedures with our IQ test information. And then we'll work on something else for matched pairs.